This object, 3I Atlas, was within a distance of 203 million kilometers from the sun. It received about 770 watts of solar irradiation power per square meter. So that's the point in its path where it gets heated the most. And indeed, there was a detection of it getting quite bright, much brighter than before, by a factor of 5 or so, by various solar observatories that looked at it, even though it was hidden from view from Earth, because the Earth was on the opposite side of the sun when it was closest to the sun. Maybe for a good reason. It's not clear whether it's natural or technological. But at any event, these observatories noticed that it became bluer than the sun, which is quite unusual because usually comets shed the dust that makes them red, or they have a surface temperature that is much cooler than the surface temperature of the sun, and therefore they appear redder than the sun. And nevertheless, 3I Atlas became bluer than the sun, which is surprising.
20 hours ago, Avi Loeb published new data that changes everything we thought we knew about 3I Atlas. The interstellar object just got 5 times brighter after passing behind the sun. The non-gravitational acceleration is now confirmed at 3.7 standard deviations. And according to Loeb's calculations, this means one of 2 things. Either 3I Atlas lost 13% of its total mass in just 1 month, which should create a massive debris cloud we can detect, or it has a technological propulsion system, a rocket engine. There is no middle ground anymore. The data from NASA's Minor Planet Center and the Jet Propulsion Laboratory just eliminated the gray area. Within the next few weeks, when ESA's JUICE spacecraft and ground telescopes observe 3I Atlas, we'll know which scenario is real. Either we see a giant gas cloud from natural mass loss, or we don't. And if we don't see that cloud, Loeb says it's a technological signature of a propulsion system. Let's break down what just happened. The new data. Yesterday morning, the Minor Planet Center and NASA's Jet Propulsion Laboratory released new observations of 3I Atlas covering October 31st through November 4th. This is the first post-perihelion data we've gotten since the comet disappeared behind the sun. And immediately, Avi Loeb analyzed it. Here's what the data shows. First, the brightening. When compared to observations from October 5th through 8th before perihelion, 3I Atlas brightened by a factor of 5 in the green wavelength band centered at 0.464 micrometers, 5 times brighter. That's not normal brightening from solar heating, that's explosive activity. Second, the acceleration. The non-gravitational acceleration, meaning movement that can't be explained by gravity alone, was confirmed again. Previously measured on October 29th at perihelion, it's now been reduced by about 1/3, but Loeb says that reduction is within the margin of error. What matters is this. The detection is now more robust, 3.7 standard deviations. In scientific terms, that means there's less than 0.01% chance this acceleration is random noise. It's real. The object is accelerating in ways that gravity cannot explain. Third, the components. The acceleration has 2 parts. A radial component pushing away from the sun at 94 kilometers per day squared, and a transverse component perpendicular to the sun's direction at a smaller rate. This is exactly what you'd expect from either outgassing jets on a comet or thrust from a propulsion system. The question is, which one? The mass loss calculation. Here's where Loeb's math gets brutal. If this acceleration comes from natural outgassing, like every comet we've ever studied, then physics demands a specific amount of mass loss. Loeb calculated it. The formula is simple. To produce this level of acceleration through gas ejection, 3I Atlas must have lost at least 13% of its total mass. Think about that. In just 1 month, the time it took to reach perihelion and pass it, this 5-kilometer-wide object would have had to eject 13% of its total mass into space. That's billions of tons of material. For comparison, most comets lose less than 1% of their mass during a close solar approach. 13% is catastrophic evaporation. But here's the key part Loeb emphasizes. That 13% figure assumes the gas is being ejected at 300 meters per second, which is the maximum thermal speed you'd expect from molecules heated by the sun at that distance. If the ejection speed is slower than 300 meters per second, the required mass loss goes up even higher. If it's 200 meters per second, the comet would need to lose around 20% of its mass. If it's 150 meters per second, we're talking 26%. At those levels, the comet wouldn't just be outgassing, it would be disintegrating. So what should we see if this is natural? A massive debris cloud. Tons of gas and dust spreading out around the nucleus, a bright and expanding coma visible from Earth. Loeb writes, we should see a dense cloud of gas around it in November and December. ESA's JUICE spacecraft will observe it in the first week of November. Ground-based telescopes will see it on December 19th, when it's closest to Earth. If there's no dense gas cloud, then natural evaporation is not the explanation. The alternative explanation. Loeb doesn't bury the lead. He states it directly in his article, quote, "A technological rocket engine could expel gas through its exhaust at much higher speed, thus reducing the required fraction of the mass loss." Let's unpack that. A natural comet ejects gas slowly, heated molecules escaping the surface at thermal speeds around 300 meters per second. But a rocket engine? That's different. A chemical rocket can expel exhaust at 3 to 5 kilometers per second. An ion drive can go even faster, tens of kilometers per second. If 3I Atlas has any kind of propulsion system, the gas would exit at much higher speeds, meaning far less mass needs to be expelled to create the same acceleration. Instead of losing 13% of its mass, it might only lose 1 or 2%. And 1 or 2% evaporation, that's nearly invisible. You wouldn't see a massive gas cloud. You'd see what we're seeing right now. Some brightening, some activity, but nothing catastrophic. So here's the test Loeb is proposing. In November and December, when 3I Atlas is observable again, we look for the debris cloud. If we see a massive, dense cloud of gas, the kind that would account for 13% mass loss, then it's a natural comet undergoing extreme evaporation. If we don't see that cloud, then the acceleration is not coming from natural outgassing. And if it's not natural outgassing, what else could it be? Loeb's answer is a, quote, technological signature of a propulsion system. He's not speculating anymore. He's describing a falsifiable test. Either the gas cloud is there, or it's not. And if it's not there in December, we have a serious problem. The anomaly count keeps growing. In his latest article, Loeb updates the anomaly list for 3I Atlas. We've been talking about 8 anomalies for weeks, but with this new data, the case is getting stronger. Here's the updated list. Anomaly 1. Trajectory aligned within 5 degrees of the ecliptic plane, probability 0.2%. Anomaly 2. Displayed a forward-pointing jet in July and August, unprecedented for natural comets. Anomaly 3. Mass is 1,000,000 times larger than Oumuamua, 1,000 times larger than Borisov, while moving faster than both, combined probability less than 0.1%. Anomaly 4. Arrival time fine-tuned to pass near Mars, Venus, and Jupiter while being unobservable from Earth at perihelion, probability 0.005%. Anomaly 5. Nickel to iron ratio matches industrial alloys, not natural space rocks. Nickel to cyanide ratio orders of magnitude higher than any known comet. Anomaly 6. Low water content, only 4% compared to typical 80%, indicating formation in an extremely cold environment. Anomaly 7. Extreme negative polarization never observed in any solar system object. And Anomaly 8. Originated within 9 degrees of the 1977 WOW signal. And now we add the 9th. Anomaly 9. Non-gravitational acceleration at 3.7 standard deviations requiring either catastrophic mass loss or artificial propulsion. 9 documented anomalies. Loeb has ranked 3I Atlas at a 4 out of 10 on his scale for potential technological origin. That ranking was before this latest data. With the acceleration now confirmed more robustly, and with the binary test coming in December, that ranking might increase. What happens next? Here's the timeline. Early November, this week, ESA's JUICE spacecraft will attempt observations using multiple instruments. It's about 0.4 AU away from the comet. We won't get that data immediately. JUICE transmits slowly, and scientists expect results in February, but if there's something dramatic, it might leak earlier. Mid-November. Ground-based telescopes will reacquire 3I Atlas as it emerges fully from the sun's glare. Starting November 11th, amateur astronomers with decent equipment should be able to see it in the pre-dawn sky. If there's a massive gas cloud, we'll start seeing reports immediately. December 19th, closest approach to Earth at 270 million kilometers, this is the definitive observation window. Every major telescope will be pointed at it. If the gas cloud isn't there, if 3I Atlas looks relatively compact and intact, then Loeb's technological signature hypothesis gains serious weight. March 16, 2026. 3I Atlas passes within 54 million kilometers of Jupiter. NASA's Juno spacecraft could observe it, possibly even scan for radio transmissions. This is the last chance for detailed observation before it leaves the solar system forever. Avi Loeb just gave us a falsifiable prediction. Not speculation, not theory. A test. If 3I Atlas lost 13% of its mass naturally, we'll see a massive debris cloud in the coming weeks. If we don't see that cloud, the acceleration came from something else. And something else means propulsion. Within 60 days, we'll have our answer. Either this is the most extreme natural comet ever observed, evaporating at unprecedented rates, or it's not a comet at all. The data doesn't lie, and the data just eliminated the middle ground. I'll be tracking this closely. Subscribe for updates when those December observations come in. Because if that gas cloud isn't there, everything changes. Thanks for watching.